Today we're going to be talking about functions, and in particular we're going to be identifying functions. To identify a function, the first thing you need to know is what is a function, and we introduced this on Friday. A function relates an input to an output, and the definition of a function is for every input there can be only one output. That is the classic definition of a function. Okay, why do we call them functions? Because we like to name them. So when you get deeper into algebra, and especially algebra 2, you're going to be comparing functions. And so they're equations, right? But if I want to say, hey, compare this equation to this equation, I name them. The classic name is f. And the way that you would pronounce this is f of x. So this function's name is what? F. So what if I wanted to name it g? I would write g of x with g with the parentheses x. But it's pronounced f of x, g of x, m of x. And that's how we name a function. And we do that, again, so that we can compare line g to line m or whatever. So it's just a fancy way to name a function. Does that make sense? Okay, again, what are we only caring about when we're identifying a function, the x or the y's? The x's. What do we care about? The x's cannot repeat. So I want you to write that, or I wrote it right here. To identify a function, simply check to see that no x repeats itself. So either circle that or highlight it. All you care about is that the x's do not repeat. The y's can repeat as much as they want to. The x's cannot. So we're going to look at ordered pairs, tables, mapping diagrams, and graphs, and we're going to be able to identify a function just by looking at it. So there's really no math involved in this today. It's just knowing how to identify a function. So let's look at ordered pairs. So we're going to write yes or no. So everybody highlight the x's or circle them. If you don't have a highlighter, you can just circle them. We highlighted the x's because we only care about the x's. So look at the x's. -1, +1, 2, 3, 4. Do any of those x's repeat? No. So this is a function. Okay, let's look at this one. Highlight your x's. I have -1, +1, 2, and -1. Did you see anything that repeats? Which one? The -1. Because these repeat, this is no, not a function. The reason would be for every input, there's more than one output. There should be for every input, there's exactly one output. All right, let's do the next one. I'm going to highlight the x's. I have 2, 3, 4, 5, 6. Did any x repeat itself? No. So this is a function. I don't know why my C's are so big today. And then this one, I have 1, 1, 1, 1, 1. Not a function. Why? All of the x's were repeating. So this is not a function. Okay, any questions on ordered pairs? Okay, let's go on to tables. Tables are exactly like ordered pairs. They're written pretty much in the same form, just all the x's are stacked. So all you're going to do is look at the x's, and the x's are the inputs, right? All right, so let's look at the first one. I have -1, 0, +1, 2, 3. Is that a function? Yes, so this is a function. Okay, let's look at this one on the right. I have 3, 4, 5, 4, 10. What did y'all see? The 4s repeat. This is no, not a function. Okay, let's look at the next one on the bottom left. I have -2, +2, 0, and 4. Is this a function? Why is this a function? No x repeats itself. And the last one, I have 2, 3, 4, 2. Yes or no? Why not? The 2's repeat. This is not a function. Okay, now we're going to look at mapping diagrams, and we talked about mapping diagrams on Friday, so I shouldn't have to explain too much to you that these are just ordered pairs, yes? The easiest way to tell if a mapping diagram is a function is to cover up the output column and only look at the input column. If every input only has one line coming out of it, it's a function. So do y'all see how -1 only has one line? 0 has 1, 4, 7, 8, 12, and 13. They all have one line. That means for every of those inputs, there's exactly one output. This is a function. If you need to write it out how I taught you on Friday, you absolutely can. You could go over here and put -1, you could make a table, goes with 8. 0 goes with 8. 4 goes with -6. Y'all see what I'm saying? You could go write it out, and you would see none of these repeat themselves. So 7 goes with -2, 8 also goes with -2, 12 goes with 5, and 13 goes with 17. You can see none of these x's repeat themselves, but it's much easier to just cover it up and see if there's only one line coming out. Okay, let's go to this one. Do it the way I taught you, cover it up. Does 0 only have one line coming out of it? No, that means if I made a table, just so y'all can see, 0 would be assigned to -2 and 0 would be assigned to 1. This right here would make it not a function. The fact that the 0 has 2 lines coming out. So I don't expect you to write a whole table. I just want you to understand why. Okay, go to this one. A lot of people will just jump the gun and say, no, this isn't a function. What do you think confused them? They're all pointing to what? Do I care about the outputs? That's why I said cover them up so you can't even see it. Does every input have exactly one line coming out? That means it is a function. None of the x's are repeating. Okay, try this one on your own. Function or not? Why? The -9 has 2 lines coming out, which means it would repeat itself. All right, any questions on mapping diagrams? All right, now we're going to go to graphs. How can you tell if a graph is a function? There is a trick called the vertical line test. Do y'all know what a vertical line is? Straight up and down. You're going to draw a vertical line, and if it touches the graph only once, it's a function, meaning the x will not repeat. And I'll show y'all what I mean. If you draw a vertical line and it touches more than once, then it is not a function because the x is repeating. Okay? So, what do I mean by if it touches what? I'm talking about the picture on the graph. Please don't look at the x and y axis. That's just the canvas that the graph is on. Yes? So if you look at this example, I am only talking about this line right here. Is that line a function? So I take my pen or pencil and I draw a vertical line like this. How many times did that vertical line touch the picture? Once. Draw another vertical line. It better only touch once. So if I draw another vertical line, it touched how many times? Once. So I can draw as many vertical lines as I want, but every time I draw a vertical line, it can only touch one time. That means it is a function. And guys, functions do not have to be straight lines. They can be crazy squiggly lines. The rule says as long as a vertical line will only touch it one time. Okay, let's look at the next example. What am I looking at? This oval. If I was to draw a vertical line, how many times would it touch? 2. What does that mean? Okay, let's talk about y. Y'all are correct. That is not a function. But everybody's eyes on the board real quick. If I made a table from this coordinate and this coordinate, wouldn't I be at negative 20, I don't know, what is that, like negative 7 maybe? And then I would also be at negative 20, negative 12. Do y'all see how that is an x that's repeating itself? So if the vertical line touches more than once, that's saying that that x repeats itself. Therefore, the answer is not a function. Okay, let's look at the next one. Where's the picture at? You have a curved line over here that stops. It's like a curved segment. And you have a curved segment over here. Does it say that it can't have curves? Nope. What is the only rule? If I draw a vertical line, it can only touch. So if I draw a vertical line over here, how many times is it touching? Once. What about over here? If I draw a vertical line, how many times is it touching? Once. So is this a function according to the rules? Yes, it is. Why? Because every x has only one output. Okay, let's look at this one. Here's my line or my graph. If I draw a vertical line, how many times does it touch? Once. If I draw a vertical line here, how many times is it touching? Once. Therefore, this is a function. What is the reason? Hey. For every input, there's exactly one output. All right, let's look at this one. Draw your vertical line. And then put your answer and see what you think. How many times did your vertical line touch? Once. So this is a function. All right, try the last one on your own. Okay, if I drew a vertical line, how many times does it touch? 2. So this is not a function. Okay, turn the page. Now we're going to take and apply some of this. So what was this called? A mapping diagram. It wants you to take and graph the coordinates and then say if it's a function. So if we graph this, I have an x at negative 1, and then I would go down to negative 2. So there would be a dot right here, yes? I would go to the x at 1, and I would go down to negative 1. I would also have a dot on the x at 1 and up 0, so it would just be on that x-axis. I would go to the x value at 2 and go up 2. And then I would go to the x value 3 and also go up 2. So is this a function or is it not? Why not? 1 repeats itself, and you can see in a vertical line test, it is touching 2 dots. It cannot touch 2 dots. Do y'all agree? Are y'all okay? All right, now it wants you to take this coordinate plane that has a graph on it, and it wants you to make a mapping diagram out of it. So I would go to the first dot, just pick a dot, it doesn't even matter. When x is negative 2, what is y? 0. So I would draw a line. Okay, I did that one. When x is negative 2, y is also, isn't this x is negative 2 right here? What is y? So this has an x value of negative 2. What is the y value? So it also has a y value of -3. Okay, so I did these two dots. This dot has an x value of -1 and a y value of +1. This dot has an x value of 0 and a y value of -2. And this x has a value of 1 and a y value of 1. So do I already have 1 written over here? So I would just draw an arrow to it like that. Why is this not a function? -2 repeats itself. And if I drew a vertical line right here, it's going to touch 2 times. So this one was no and this one was no. Okay, I want y'all to draw a mapping diagram on your own based on that table. Was this a function? Why? 1 repeats itself. Okay, this one says rewrite the relation as a set of ordered pairs. What does it say? Not a. So we're going to write ordered pairs on this. So I'm going to start right here. What is this ordered pair? Ooh, where is it at on the x-axis? Ooh, on the x-axis, -3. Where is it at on the y-axis? 0. All right, let's do this one. Where am I at on the x-axis? -2. Where am I at on the y-axis? -3. Okay, this one, where am I at on the x-axis? -1, and the y-axis, +1. Okay, let's go to this one. Where am I at on the x-axis? 0, the y-axis, 2. And then this one, where am I at on the x-axis and the y-axis? It says, is this relation a function? Why? No x repeats itself. And if I drew a vertical line, each vertical line is only touching 1 dot. Okay, so yes, this is a function. Okay, on the bottom it says identify the domain and range. We're not learning that today. That's actually a very challenging lesson that I think we're doing maybe tomorrow. I think we're doing it tomorrow. Let me see. Yep, tomorrow is that lesson. I just want you to say, is it a function? So let's look at this one. Now, do y'all know what this solid dot means? That there is a point there. Do you know what an open dot means? There is not a point there. Okay, so just so y'all know, if I drew a vertical line, how many times did it touch? How about over here? Is this a function? Yes. Why? Because I drew a vertical line and it means no x repeats itself. For every input, there is only 1 output. How about this one? Why not? Touch twice, which means what? The x repeated itself. Okay, over here, did it touch once? Yes. Did it touch once? Yes. So therefore, this is a function. Okay, put your name on it when you get it. Remember that this whole assignment is identifying functions. Make sure you read the directions carefully because it might say which table is not. It might say which table is a function. And then be careful, like on the back, you have to read what it says. Like on the bottom, it says circle every relationship that is a function. So there's more than one answer. Yes? When you get to this page, it is a cut and paste. So this very back page, you're going to cut them out. You're going to put all the functions on the left side that are yeses and the no's on the right side. Make sense? All right, you may get started.